Okay, for 4.1, we have to calculate the angle. So this is the formula. The arc length is equal to the radius times the angle. Now, so here, let's just reformat it. Let's divide off the r. All right, so theta is going to equal to s, which is the arc length, which is 150 divided by 80. Let's just knock off a 0. So you can leave it as 15 over 8 radians. Radians is like our unitless unit, or you can convert it to a decimal. All right, I think the second one you asked me, you guys asked me, was a little easier to see because there was like a picture. So it's the same formula, it's the same concept. We're going to calculate theta again. So the idea is, when you look at the picture, is that the arc length is proportional to the radius. All right, so the arc length here they're giving is 28. The radius here is 7. We're calculating the angle. So again, I have to divide off the r. So theta is equal to s over r. So it's a proportionality concept, right? So whether the circle is small or whether the circle is large, the arc length will be in proportion to the radius. All right, so the arc length here is 28. The radius is 7, so the angle will be 4 radians. Now remember, radians is a different unit than degrees, right? And I did in lecture the conversion between radians and degrees, and you can go ahead and do that if you want to, right? So if you're going to convert from radians to degrees, so this is in radians right now. So if it would make a little more sense, leave it on the test in radians, but if it would make a little more sense to see this in degrees, it would, some people do degrees better than radians. So it'd be 180 degrees over pi radians. So the radian unit cancels, and you're going to have 4 times 180 divided by pi. All right, so that is, if it's a little easier for you guys to understand, that would be equivalent to 229 degrees, right? Which makes sense. I didn't draw this exactly to scale, but you know 180 degrees is here, and we've passed 180 degrees. All right, gang, that's it. So this is the formula you would use. Arc length is equal to the radius times theta. And if I wasn't super clear, let me be super clear. This formula only takes angles in radians. If you're given the angle up front and you're searching for one of the 2 other pieces, your angle must be in radians, not degrees. If it's in degrees, you're going to get the wrong answer. So make sure it's in radians. Okay, catch you. Bye-bye.